Hello, and welcome to an episode of Physics Magic featuring yours truly, Gael Garcia. In this episode, we will conduct an experiment that will give an amusing demonstration of the physics of music. Follow along as I demonstrate these few simple steps, and soon enough, you'll have your very own straw oboe. By the end of this episode, we will be able to make a wind instrument that changes pitch when the length of the straw is manipulated. You will need a few materials to make your straw oboe. You will need straight plastic straws, the ones that don't have a bendy bit, scissors, your mouth, and maybe some water to drink when you're practicing playing your instrument. To start, flatten one end of the straw. You can put the straw in your mouth and pull the end of the straw through your closed teeth to get it flat. Next, make two cuts in the now flattened end of the straw to form a triangular tip like an arrow without its sharp end. After making sure that the ends are cut equally, put the triangular tip of the straw into your mouth with your lips closed tightly around the straw. Blow into the straw, making sure that the only exit of air will be through the straw. If done correctly, you should hear a loud buzzing sound like this. If you don't, you may need to move the straw to different positions to get the sound right. Now here comes the fun part. While blowing to the straw oboe, cut the straw shorter around 1 centimeter at a time. With each cut, you will hear the pitch of your straw oboe go higher. Now, how can something you used to drink iced tea with on a hot summer day turn into this cool little instrument? This is where physics comes into play. In this experiment, we dealt with waves. Standing waves can be observed in physical media such as strings and columns of air. Any waves traveling along the medium will reflect back when they reach the end. This effect is most noticeable in musical instruments where, at various multiples of a vibrating string or air column's natural frequency, a standing wave is created, allowing harmonics to be identified. The flattened triangular tip acts like the reed found in most wind instruments. Blowing on the reed causes the straw to vibrate. This vibration creates a standing wave pattern along the length of the straw. This wave pattern is what we hear as sound. Remember when the straw got shorter and shorter and the pitch of the sound it was making went higher and higher? This is because as you shorten the straw, you shorten the wavelength of the standing wave pattern that you create when you blow into the straw. A shorter wavelength gives off a higher pitch, therefore, when you shorten the straw, you increase the pitch of the note being played. Right now, you have an instrument that can only play one note at a time. It can only play a different note when you cut it shorter, so you can't really say it's a long-lasting instrument because before you've finished playing a single song, all that's left of your oboe is pieces of straw on the ground. To improve your straw oboe, you will need some additional materials which include a metal paper clip and a lit candle. Take the paper clip, unfold it so you have a long piece of metal, bring it to the flame for a couple of seconds, and use it to poke holes on one side of the straw, making sure that they are relatively equidistant from each other. The size of the hole should be around half the diameter of the straw so that it won't produce squeaky sounds. After the molten plastic dries, you can now try your new and improved oboe. Covering and uncovering the holes changes the pitch of your instrument without it getting shorter and shorter. But wait, there's more! If you take an envelope and cut the corner off at a slight curve, you will have a little cone bag. Cut off the corner of the bag just big enough to fit the straw through. Put the straw in reed first, and now you have something that will amplify the sound. Now you have a world-class, homemade drinking straw oboe ready for standing ovations in concertos around the globe.